right, we are covering 6.3 today, which is logarithms and logarithmic functions. So it's another introductory section. So it's going to be a bunch of little stuff. Okay, all the little things you need to know about logarithms, and then we'll do more with them later. Okay, so a bunch of little things going on. First off, with your warm up, I wanted you to see, can you notice a pattern? Okay, so if log base 2 of 8 equals 3, if log base 5 of 25 equals 2, and log base 10 of 1,000 equals 3, okay, could you tell me what is log base 7 of 49? 2. All right, good. How about log base 3 of 27? 3. Good. How about log base 2 of 32? 4. 5. Should be 5. How about log base 4 of 64? And log base 2 of 1/2? -1. Okay, so how did we do that? What is the relationship that we're seeing? If it's log base b of y equals x, how does the bxy relate to each other? Yes, keep going. Equals what? Equals y. She said b to the x equals y. So all of my bases. So do we agree that 2 to the 5th is 32? 7 squared is 49. 4 cubed is 64. Yeah? 2 to the -1 power equals 1/2. Yeah? So that's the relationship between these, okay? So logarithms and exponentials, they are best friends. Okay? Before, you could not find a missing exponent, because before we would do the root that matches the power. If you don't know the power, you don't know the root. Okay? Instead, we have logarithms. So logarithms always equal exponents. Okay? Scroll for me. Okay? So we know 2 squared is 4. We know 2 cubed is 8. All those were nice numbers. But what if I said 2 to what power is 6? Right? That's when we are going to use a logarithm to find it. Okay? And I would use log base 2 of 6. I would evaluate that to find the missing exponent, which is not going to be a whole number, right? It's not going to happen. There's 2, it's in between these guys somewhere. It's going to be 2 point something, right? Does that make sense? We know it's going to be in between the exponent of 2 and 3, but we're not sure where. Yeah? So they do get rewritten back and forth. The logarithm of y with the base of b, we write that as log little b big Y, like that. Make sure your b is tiny. Okay. The first thing we're going to look at is going back and forth between forms. Okay. So if you have the word log, that is a logarithmic form. So if I'm asking you to rewrite it into logarithmic form, I'm asking you to write the log. Okay? And then vice versa, my other one is called the exponential form. So if my x is in my exponent, that's exponential. All right, so let's rewrite some of these. Okay, so log base 2 of 16 equals 4. How can I rewrite that as an exponential equation? What's my base? 2. I even say it, don't I? Didn't I say log base 2? Yeah? So that base is the same. So my base is still 2. What's our exponent? 4. And we're equal to what? 16. Okay. Okay. There's a little trick if you want it about rewriting. If you want the exponential, you can actually draw the letter E, and it helps you out. Like right here, I would say 4 raised up to 0 equals 1. And you can like draw the letter E. 4 raised to 0 equals 1. So that's a little trick. Use it, don't use it. Your call. All right, Zachary, what's part C gonna be transformed into?
12 to the first power equals 12.
Beautiful. Calling somebody for me. Jaden, how about part D?
5 to 1/4 power 4 equals
To the power of what?
-1.
There you go. Good. Good. We're always equal. Logs are always equal to my exponents. So that's your exponent of -1. Good. Questions? Now we're going to go the other way. I'm going to give you an exponential. I want you to write the log. Okay? So my first one, I have 5 squared equals 25. So what is the base of my log? 5. Log, little base 5 of 25 equals the exponent, which is 2. Like that. And with these, you can draw an L. So if you want a log to draw an L, like a capital L, you would go straight down, kind of like that. So base 5 of 25 equals 2. It's a weird looking L, but you get the L shape, right? All right, what is going to be the log form of part B? Jaden, text somebody. Emily, part B.
Log 10 base 10 0.1 equals -1.
Good. Emily, calling somebody.
Chloe.
Chloe, part C. Time to shine. You got this. Log base 8 of 4. Good. Equals. Yes. Good. All right, Chloe calling somebody. Hooper. You knew it was coming. All right, part D.
Log base 6. 1 over 260.
There you go. Nice. Good. So our first little bit was rewriting back and forth. Okay. Something just to draw your attention to, on part B and part C, from writing them into exponentials, this showed us 2 special properties of logarithms. Okay. Logarithm of 1, meaning if your log equals 1, it doesn't matter what your base is. Okay. It'll always equal 0. So right here was log base 4 of 1. Well, if I have a log of 1, that means your exponent had to be 0, no matter what the base is. Okay? Log base 35 of 1 has to be 0. Okay? Because you can only raise it to an exponent of 0 to make it equal to 1. Does that make sense? Yes? So that's what this is showing right here. And it does not matter what this base is. If there's a log of 1, it will always equal 0. Okay? And in the second special case, when my base and my value are the same thing, your b and your y, it has to equal 1. Because a base raised to 1 always equals itself. Okay? And that showed up in part C. So see like the 12, 12, that was 2, 2. A million. Okay? If those are the same number, it has to equal 1. Cool? So special things to pay attention to. And this guy is going to show up when we start solving. It's going to help us a lot. Okay? All right, this next little section, so we're moving on to the next little topic. Are we cool? We good? Okay. Next little topic is evaluating. Okay? So looking at these, a lot like your warm-up. Okay? Log base 4 of 64. No calculator. What does that equal? 3. Good. It equals, we don't know. I can rewrite this as 4 to the power of x equals 64. So x equals 3. Like that. Okay. My next one, log base 5 of 0.2. Okay. So that's equal to a missing exponent. So 5 raised to what equals, and I'm going to rewrite 0.2 as a fraction. What is 0.2 in fraction form? 1 over 5. Because that helps me see some properties that happened. What is my exponent? -1. Good. Nice. Cooper, calling somebody. Ready? Help me rewrite this in exponential form. Where is it? Caden or Canaan?
Canaan.
Canaan. There we go. Sorry.
-3.
Okay, help me rewrite it first. You're right.
1/5 the x equals -3.
Well, equals 125. And then your x equals 3. Yes, good. Okay, it's negative because it went from a fraction to not a fraction. So we knew some flipping happened. Okay? And then 5 cubed is how we get to 25. So -3. All right, Canaan, next person. Now it's Canaan. All right. Help me rewrite part D.
36 to the x equals 6.
Good. Almost. You're thinking of the right thing. It's not going to be 36 to the power of 6. Right? What do you think? This one's kind of tricky, so you can definitely phone a friend if you need to. No? So it's getting smaller, right? He's thinking, he's trying to get there, right? A negative wouldn't make it smaller, though. It flips it as a fraction. I know, it's kind of sneaky. You got the hard one. What would make 36 turn to 6, just in general? No? Vin.
1/2.
Okay, why 1/2?
Because if 6 squared is 36, then 6 power 1/2, then 36 power 1/2 is 6.
There you go. You were. And it's been a hot minute. It was back in chapter 5, which is before I left, okay? A power of 1/2 is the same thing as a square root. So you were almost there. You wanted to divide by 6. 36, the square root of 36 gives me 6. Okay? So your thinking was correct. And to make that happen, our power is 1/2. Okay? Power of 1, root of 2. Yeah? Cool? Because we're going to move on again. Okay? We have some special logarithms. Okay? You'll notice you have 2 buttons on your calculator. There is a log button. Okay? It is going to be associated with something called a common log. Okay? That button has a base of 10 and nothing else. Okay? So if you have like a log base 7 of 21, you're not going to push that button. Okay? The log button on your calculator is only for log base 10. Okay? You will see it written. Sometimes it has a base of 10. Sometimes it's not written. Okay? So just the word log, you're going to assume base 10. Like we don't write exponent of 1. Right? We don't usually write base of 10. They go together. Our other special log is your other button, which we've actually already pushed. Okay? Remember we pushed it to get the E? The natural base E for 6-2? This is called a natural logarithm, so they go together. A natural logarithm has a base of E. So you might see it as log base E of x, but the most common way to see it is that ln, the natural log. Okay? And that button is next, I believe it's next to your 4, right? And then log is above that. Okay. So this next part is purely just, can we type it in and match? Okay? So can you type in log 8? Natural log 0.3. I bet you can. When you type in log 8 and it tells you to round to the 3 decimal places, what do we get? .903. And if we type in natural log of 0.3, we should get about what? It's next to the 4. Okay, so log 8, right? This was our first one. There's that 0.903. The one we're doing right now, the natural log of 0.3. Natural log is right here next to the 4. 0.3. I'm going to close my parentheses and push enter. Okay. Now, does it matter? Do you think log of 0.3 is the same thing or different? It's different. So does it matter which ones you push? Yes. Okay. So natural log of 0.3 is negative 1.204. Okay. You try the next two. So this is, can you type it in? Make sure we know where those buttons are, because you are going to use them a lot. Okay? Caden, pick somebody.
Danny.
Danny, what did you get for log 12? 1.079. Good. Danny, calling somebody. Wyatt? All right, Wyatt, what is the natural log of 0.75?
Negative 0.288.
Yes. Negative 0.288. We good? We got it? We can push buttons? Yeah, you can. Okay. Because now we're going to go on to the next little topic. I know. The next topic is called inverses. Okay? So exponentials and logs, they're together in this unit because they are inverses of each other. Okay? The log function, log base b of x, is the inverse of exponential b to the x. Okay? Means that if I do the composition of the two, I get just x. Log base b of b to the x. Remember when the b's were the same? They got to cancel out. Beginning, what was it? Log base 12 of 12. They canceled out, we were just 1. Okay? So here they would cancel out, I would get x. Okay? On the other side, a base raised to a log with the same base, they also undo each other, leaving you with just x. Okay? So if I have a log and an exponential written together with the same base, they will undo each other. Right? So let's use the inverse property to simplify, and then I'm going to find actual inverse functions. Okay? So looking at this one, I have 10 raised to log 4. Okay? Well, I need to know what is the base of that log. But it's not there. It is 10. This is a common log. Okay? So this is technically 10. Come on. There we go. Raised to log base 10 of 4. So see how I have 10 log 10? Those can cancel. This is just 4. That's it. Okay? Sometimes it is very much straightforward in your face. And then sometimes, like part B, we gotta do a little manipulation to make it happen for me. Okay? Because if that was a 5, 5, they would cancel out. Right now it's 5 and 25. Okay? But could I rewrite 25 to somehow be a 5? Yes, how? How can I rewrite just the number 25? It still equals 25. Yes.
5 times
5 times 5, which is 5 squared. So right here, log base 5 of 5 squared to the x. So it's the same thing. I haven't changed the problem. 5 squared is 25. So instead of 25 to the x, now it's 5 raised to the 2x. Okay? Because now I have 5. The base of my log is 5. The base of my exponent is 5. They get to cancel. This simplifies to just 2x. All right. So now I'm going to apply this to inverse functions. Okay. This was what we did when I came back in 5-8. Okay. We did inverse functions. Okay. Meaning this is f of x equals 6x, right? That's y equals 6x. What do we do for inverse functions? We switched our x and our y. That should be raised to the x. That does not look like an exponent. There we go. We're going to switch my x and my y. So now we're going to have x equals 6 raised to the y. Now to get y by itself, I need a logarithm, right? Because y is the missing exponent. So what is going to be the base of my logarithm? What's the base of my exponent? 6. So I need a log with the base of 6 to undo that. Okay? So you're going to log base 6 like that. If you do it to one piece of the equation, you got to do it to the other, right? They both are going to get a log base 6 brought in. So over here, they get to cancel. That's the whole point. And now we have y by itself. So our inverse function is going to be log base 6 of x. So 6 to the power of x, log base 6. They are inverses of each other. You okay? When we start like solving, which I believe is section 5, we're going to be doing a lot of this over and over and over again. Okay? All right, my next inverse function, it has f of x equals the natural log of x plus 3. So that's technically a y equals natural log of x plus 3. So my inverse, I'm going to switch that. So I'm going to have x equals natural log of y plus 3, like that. Okay.
Wouldn't you have to do the opposite of like whatever the natural log implies?
Okay, yeah, so the opposite would be what is the base? What is the base of this log? If it's a natural log, what's my natural base? E. So we're going to bring in a base of e to both sides. So yes, that's technically doing the opposite, is bringing in the base. Okay, so I'm going to have e raised to x and e raised to natural log of y plus 3. Does that make sense? What I did right there? So those get to cancel. I have e raised to the x still, and we are equal to y plus 3. So it's no longer an exponent because my natural log and my base got canceled out. This x is still an exponent. All right, final step is going to be to subtract 3, right? So we have our inverse function is going to be e raised to the power of x and then minus 3. That is the inverse of natural log of x plus 3. Bless you. All right, last little mini topic is the graphs. So any questions on the inverses? Because we're going to actually use that to graph it. All right. So since they are inverses of each other, they still reflect over the y equals x line, meaning their coordinate points still switch places like it did for our other functions in section 5.8. Okay. Your domain and range also switch. Your asymptotes also switch. Okay. Your asymptote for an exponential was the x-axis, the y equals 0, right? Your asymptote for a logarithm function is now x equals 0, or your y-axis, okay? So that also flips. So that's going to affect your domain, right? Last time with your range, your end behavior like went towards 0, right, for your y's. Now that we flipped it, my domain is going to have a stopping point, okay? My end behavior for my x's is going to associate with the asymptote. Okay, so everything flip-flops. Okay, so we're going to graph log base 3 of x. Okay, again, you can't type that in, not yet. So instead, we're going to graph the inverse first. So the inverse of log base 3 of x is 3 raised to the x. So we're going to graph that one first. So let's fill in our table for 3 raised to the power of x first. Okay, this is an exponential. So we're going to have an asymptote of y equals 0. We know it's going to be a growth. So let's get some key points there. So go to y equals, that's not what we're doing. We are doing 3, raise it up to x, like that. And then go to your table. All right, what do we get for negative 2? Not 3.1. 0.1? Okay. 0.1, which is the same thing as 1/9. 3 to the negative 2 power makes sense. It flips, and then 3 squared. All right, when the negative 1, we got 1/3. For 0, we got 1. For 1, we got 3. Okay, this is 3 to the power of x. Okay, so my domain is all real. My range is only y is bigger than 0, right? So we can expect all that to flip-flop when I do my log now. So now that I have an exponential, I can just switch my points and graph my log. Okay, so what's the first point going to be in my log function? It's not negative 2 and 1/9. Now it's 1/9 and negative 2. And then I'm going to have 1/3 negative 1, 1 0, and 3 1. Okay. And this asymptote, it's not y equals 0 anymore. Now it's x equals 0, which is now my y-axis right here. All right, here is our log base 3 of x. Now let's answer positive, negative, increase, decrease, and end behavior of the log function. Okay, so my green up here. So positive versus negative wants to know what x values make my y's positive, what x values make my y's negative. Okay, so we're looking at our x-intercept, which for this one is the point 1 0. So do we agree everything after that is going to be a positive y? So how do I say everything after the x-intercept? Will be positive when all x's are greater than 1. All right, Now, when am I going to be negative? Okay, it's not just less than 1. Because look, isn't this where it goes towards the asymptote? Right? So it's not everything less than 1. It is less than 1, but it also has to be bigger than 1. It also has to be bigger than 0. So we're going to say we are going to be negative y values in between 0 and 1. All right, increase, decrease. It's still going to be one or the other. So my entire log function, is it increasing or is it decreasing? The whole thing is increasing, okay? What is the domain, though? It's not all real numbers anymore. 0 to infinity, yes. So we are increasing. We're going to say all x's bigger than 0, or you can say 0 to infinity, same thing. Good. And we are not decreasing at all. Decrease, I'm going to say none. It does not decrease. All right, last little bit. We got this. In behavior. Okay? Left side versus right side. Okay? Here we go. On the left, are we going up or down? On the left, we are going down. Am I being restricted going left? Am I being restricted going down? To the left, because left stops at what? Left is going to stop at 0. Is anything restricting it going down? No. So when my x goes to 0, my y's go down. All right, on my right side, we are going up. Is anything stopping my graph from going to the right? Is anything stopping it from going up? Yeah, I can. My asymptote is the y-axis. So my only restriction is I can't have negative x's. That's where everything else is free range. It looks like it's leveling out. If you keep looking at it, it's going to continue to increase forever. So they're both good, so they're both positive. Infinity. Forever right and forever up. Nothing is stopping it. Only the asymptote stops it from going left, which is an x value. All right. So that was a bunch of little topics that we're going to dive deeper over the next couple days. All right.